Hello everyone! Welcome back to our math class. Let's start by answering this question. What are symbols? Symbols are signs or words that indicate an idea or relationship. Symbols are used to represent an idea or relationship and for better clarity. In mathematics, we have different kinds of symbols. So for today, we will be trying to translate verbal phrases to algebraic expressions or equations and vice versa. So we'll put symbols into words or words into symbols. But first, let us take note of these keywords. So we have for addition, these are our keywords: sum, more than, plus, increased by, added to, or total. For subtraction, we have take away, diminished, less than, or just less, minus, subtracted from, or subtracted to, decreased by, and difference. For multiplication, we have times, multiplied, product, twice means two times, thrice means three times, and so on. For division, we have divided by, quotient, divided into. And for the equal symbol, we have is, will be, and for exponent, we have square, cube. Square is to the power of 2, cube is to the power of 3. Okay, so for exponent, we have to the power of. Now let's have some examples. Let's try to translate this phrase, the sum of 15 and 6, into symbol. Okay, so since we have here the word sum, it means the operation that we will use is addition. And what we will add are 15 and 6. Therefore, we have 15 plus 6. Another one, the sum of a number and 6. Again, we have here the keyword sum, so that means the operation involved here is addition. But this time, what we'll be adding is a number and 6. There's no specific given number here. That's why it is stated a number. So in this case, since it is an unknown value, a value which we do not know yet, we'll be using a variable to represent it, just like what you learned in our last session. So that means the sum of a number and 6 can be written as x plus 6. Okay, so x is the most commonly used variable. Okay, so that's why I used X here. Okay, but you may use any other letter from the English alphabet since there's no specific variable indicated in the question. And again, X is now a variable. It is a symbol used to represent a specific value. This no longer means multiplication. Let's have some more examples. Let's try to translate the verbal phrases to expressions or equations. First, a number increased by 20. Okay, so first, let us identify the operation involved here. We have the keyword increased by. So meaning to say, we will be using addition. Now, what will we be adding? We have here a number and 20. Again, since this number is not given, we may use a variable to represent its value. So this time, I'll be using the variable y. Okay, so y, according here, will be increased by. So I will add 20 to y. So we have y plus 20. Next, 12 more than a number. Take note of this keyword here. We have more than. Okay, whenever you see the word than, it means that we will have to interchange our numbers. So instead of writing 12 plus a number, we will have it as a number plus 12. Okay? Again, take note of that. So, we'll have here more than is for addition. Then we will write 12 last, then a number first. Okay? So, again, we have here the keyword than. That's why we have to switch the position of our given numbers. Okay, so we wrote first the variable c, then we added 12 to it. Although we have commutative property for addition, we are translating these words into symbols correctly. So we have to follow this, the correct order. Next, the difference of a number and 9. So this time we are given the difference, and this means subtraction. Okay, what will we subtract? We will subtract a number and 9. Again, a number is not given. It's not a specific value, so we will use a variable to represent it. Okay, so we'll have d minus 9. Okay. Next, 7 less than a number. Okay, so you have here the keyword less than. Less than is for subtraction, and you also have here than, so that means we'll have to interchange the position of our numbers. Okay, so for less than, that is subtraction. Then we will write a number first, which in this case I used G to represent that number. Then we will subtract 7 to G. Okay, so we have G minus 7. Okay, so G minus 7 is different from 7 minus G. Okay, we may have different answers for this one. One may be positive and the other may be negative. So it's very important that we make sure to interchange the numbers whenever we have the word than. Okay, next, the product of 6 and a number. Okay, so when you say product, it means multiplication. Okay, so again, we will no longer use x to indicate multiplication because x is now a variable. Okay, so instead of writing 6 times a number which is x, we will no longer use that because this might confuse us. 6xx, okay? So we might think of this one as a variable as well, or we might think of this one as a multiplication as well. So we'll no longer use that as multiplication. So instead of using x, we may write the product of 6 and a number as 6 dot x. Okay, so dot is also a symbol for multiplication. But in algebra, we usually use parentheses. Okay, so if you have 6 parenthesis x, this also means multiplication. As long as there is no operation in between the number and the parentheses, then this one here means multiplication. But if you are multiplying a number and a variable, in algebra, we just simply put them together. Okay, so 6x, remember numerical coefficient and variable. So numerical coefficient multiplies our variable. So whenever you write a number before a variable, that means, or the operation involved between them is multiplication. Okay, so again, the product of 6 and a number is just 6x. Okay. It's a different story if you're multiplying 6 and another number. Say for example, the product of 6 and 7. You cannot write it as 6, 7 like this one because 6, 7 put together will give us a number 67, right? So instead, we put a parenthesis to 7 so that this will mean multiplication. But again, since we are multiplying a number and a letter, we can just simply put them together and that will already mean multiplication. Next, the quotient of 5x and 9. Okay, same thing for multiplication. We no longer use the division symbol like this one in algebra to indicate quotient. Instead, we express our answer as a fraction. Okay, so whenever you have the quotient of 5x and 9, we'll have it as 5x as the numerator because it's the first number mentioned over 9. Okay, so this means 5x over 9 is 5x divided by 9. Another one, twice a number increased by 16. Okay, so we have here two operations involved. First one is twice, it means multiplication. Increased by means addition. Okay, so since it was stated that we will have twice a number, it means that we will double a specific number. But this number is not yet given, so we'll use a variable to represent it. So twice a number means 2 times x. Okay, whatever the value of x is. Then after getting twice of that number, we'll have to increase. Okay, so when you say increase, that's addition. We will increase it by 16. So for our answer, it will be 2x plus 16. Another one, 10 more than thrice x is 21. Okay, so we have here two operations involved again. We have more than and we have thrice. Okay, so since there is more than here, it means that we will have to interchange our numbers. Okay, so first we have to multiply first our variable x. The variable is already given, so we cannot use any other variable here. So it says thrice x. Okay, so if you will write it into symbol, that means 3 times x, and this is considered as one number. So if you have 10 more than 3x, because of that, we'll have to interchange the position of 3x and 10. So if we will write it, that will be 3 x or thrice x plus 10. Now you have here the keyword is means equal sign. Okay, so if you will multiply x to 3, or if you'll get the thrice x and add 10 to it, that will be equal to 21 according to our statement here. Another one, the square of m is 144. So we have here a keyword is, so that means we are dealing with an equation. Okay, then we have here the keyword square. Square means exponent 2. Okay, so according to the statement, if you square m, the variable m, that will be equal to 144. So if we will write it in symbol, that will be the square, which is an exponent 2, of m equals 144. Another one, this will be our last example, 18 times the sum of r and 63. So we have here two operations involved. We have multiplication because of the keyword times and addition because of the keyword sum. So according to the statement, we will multiply 18 to the sum. Okay, sum of what number? Sum of the numbers r and 63. Okay, so according here, we have to get first the sum of r and 63 before we multiply it to 18, because it is stated 18 times the sum. Okay, so we cannot multiply 18 yet unless we find the sum. So in that case, we'll have to add first r and 63 to get their sum. Okay, so here. Now remember, in GEMDAS, multiplication should be performed first before addition. But in here, again, we are asked to find first the sum so that we can multiply it to 18. So in this case, we have to make sure that addition should be performed first. How will we do that? Okay, so we will put them into group. Okay, so we'll put a parenthesis for r plus 63 to make sure that we'll perform first addition before multiplication. Okay, so once you get r plus 63, you may now multiply it to 18. Again, there's no need for us to put the multiplication symbol here anymore, because parenthesis also serves as multiplication, a symbol for multiplication, aside from a grouping symbol. Okay, and that's it for our lesson for today. I hope you learned a lot. Thank you.